So, first video on functions covers, I suppose, the obvious question, which we kind of wonder heading into any new topic, but particularly one like this, is what is a function? What do we mean by a function? Because obviously it's a familiar word, but as is often the case, it's kind of what is this going to mean when it's applied to maths, when we're using it in maths? So a function has quite a specific definition. A function is a rule or a relation that takes a set of inputs and produces a set of outputs. Okay, so a function takes inputs, things that we put into it, and it produces outputs according to some particular rule. Okay, every or not every, excuse me. So for a relation to be considered a function, there's two specific points we have to have. Every input must have an output. So if I put something in, I must get something out. And for it to be a function, it must only have one output. I shouldn't be able to put an input in and get two different outputs. Okay, so we think of a function, and the way that I nearly picture them is nearly to think of it like a machine. Okay, sometimes we use that word, it's a function machine. So let's say here that this is my kind of function machine. And what I'm going to do is I'm going to be taking inputs. So we'll think of certain numbers. Let's do 1, 2, 3, and 4. And I'm going to take these numbers, I'm going to put them into the machine, and I'm going to get a result out of the machine. So these are my inputs, and then I'm going to have outputs as well. So the idea is that the machine has a certain rule. So let's just say that for this machine, it's x plus 2. Okay, where the thing is, I suppose, where x is what we put into it, if you like. Okay, so we'll say that here. So my input is the x part that I'm talking about here, and the machine is going to add 2. So whatever I put into the machine, I get out that 2 added to that number. Okay, so thinking about it this way, if we start with 2, let's put 2 into the machine, 2 goes into the machine, and I get out 2 plus 2, which of course is 4. If I put 1 into the machine, I get 1 plus 2, which of course is 3, and so on and so forth. If I put 3 into the machine, I get 3 plus 2, which is 5, and if I put 4 into the machine, I get 4 plus 2, which is 6. So we've lined up here that every number, every input that I have put in, I suppose all in the words, everything I have put into the machine has come out again on the other side, changed. Okay, and it's not even that it necessarily has to change, but there just has to be something produced at the end. We can see in this one as well that everything I've put in has come out differently, has been changed, and there has only been one output that has come out of it. So I've put a number in, I've gotten a number out, and only one number out. So one in, one out. So this is an example of a function. So I'm able to put inputs, usually numbers, okay, or always numbers essentially. I'm putting numbers into my function, and I'm getting other numbers out that have been changed. And all of them have been changed by the same rule. In this case, the rule was to add 2. So for every number I put in, I got out a different number, which was 2 more. Okay, that really is what I would keep in the back of my head when I'm thinking about functions. So every function we look at is going to be treated in the same way. We are going to have certain numbers that we're going to treat as inputs, and usually for those we will use the letter x. And then we will have other numbers that will be our outputs, and in no surprise to anybody, we usually use the letter y for our outputs. Okay, the letter y for our outputs. So it's a lot of kind of tying this idea together. So it's that idea of I put something into the machine, I get something out of the machine. And that's always what's kind of underlying with our idea of kind of what makes a function. So looking at that here, going back to those two ideas we said, every input has to have an output. So if I put something into the machine, I have to get something out. And also, if I put something in, I only want to get one thing out. Okay, there's 3 different ways we can write a function. The first way I'm going to start with is actually over here on the right hand side. So remember, my input, we use the letter x, and my output, Well, one of the ways that we can say an output is to use the letter y. So if we look at the one that I've boxed here on the right, y is equal to x squared plus 1. So if I think of an input here, an x value, I put that value into the function, I square it, I add 1, and I get my answer. And that's my y value, that's my output. Okay. The other way of thinking about it, I'm going to hop over now to the left hand side here, is this notation here. And we're going to get into the notation a little bit more later anyway. But to look at this notation, the way we would read this is f of x. Okay, the f there stands for the function. It's the name of the function. We think of this, or I would always read this as f with the two brackets, and what's inside here is my input. So it's kind of like a visual representation of what we saw over here with our machine. So if this is my function f, this is my x value that's gone in, and these are my f of whatever my x value was. So for my function, if I put in the number 1 into my function, the answer that I got out was 3. And that's really is always the way I would think about it. If I start with my function and I input the number 4, well, the answer I got out, my output, was 6. So we can call that f of x, f of 4, or we can call it y. The last version there just has the two little dots, and the way we would read those is we read it as maps, okay, the two dots and the arrow. So it maps an x value to x squared plus 1. So it kind of just describes what's going to happen with this rule for us here. In terms of testing functions using a mapping diagram, this is kind of where we look at, I suppose, what makes a function. Okay, and whether the relation or the kind of situation that's being described, does it qualify for a function? So we think of those two reasons, or those two kind of qualities that we described earlier. So if we look at the situation here, I have A is 2, 4, 6, 8, and B is A, B, C, and we're asked to say whether each of the following relations is a function. So looking at the first one, the relation OR says that 2 is mapped to A, 4 is mapped to B, 4 is mapped to C, 6 is matched to C, and 8 is matched to B. This one is not a function. And there is one simple reason. As input 4 has 2 outputs. One of the main things we said was that every input I put into the function must only have one output. So if I put something in, I get one thing out, and that's all. I can't put one thing into my machine but end up with two possible answers. What this does raise, which is an interesting one, is that I can have two inputs which have the same output. That's possible. But what can never happen is two outputs coming from the same input. Okay, looking at S here, 2 goes to A, 4 goes to B, that's different, 6 goes to C, and 8 goes to B. Okay, in here, each output is unique, so we'll say that. We'll say each output goes to one input. And no output yeah, and essentially that's actually, I've summarized it there. Each output goes to one input. I was going to say then each and no output goes to 2. That's just the same thing. So each output goes to an input and only goes to 1. So we would say S is a function. So here S is a function, but OR is not a function for the simple reason that one of the inputs goes to 2 outputs. To test a graph, because we're going to be looking at graphs later as well, to test whether a graph is a function, we use what we call the vertical line test. This is if I draw a vertical line, I only want it to cut the graph once. If it cuts the graph any more than once, I do not have a function. So we can see the example here where this is a function, but neither of these two are functions. So let's get into some examples here. The three curves A, B, and C are shown in the diagram. We have to say which one is not a function. So if I look at the first one, I'm going to try a few horizontal lines. That seems fine. It's only cutting them in one place. That seems good. We try the next one. Again, I'm only cutting it in one place. So that's good. If we look at C here, I am able to draw a line that cuts the function in more than one place, that cuts the graph, I should say, rather than the function, that cuts the graph here in more than one place. So therefore C is not a function. And we could give our reason as fails the vertical line test. Okay, because this is our common test for whether something is a function or not. If it is a function, it will pass the test, it will only cut it once. We're asked to give a reason why this graph does not represent a function, and you guessed it, it fails the vertical line test. What does that mean? It means that one x value maps, we use the word maps, to more than one y value. So what do I mean by that? I mean one x value, which we remember is an input, maps to or goes to more than one y value, which is an output. Okay, so there's more than one x and y happening there. Looking at the next one, then we're finally just coming to another one where we're looking at a relation. This one, state which of the following is a function. If I look at the first one, each input goes to one output, that's okay. The second one, I can see 2 there goes to 2 different outputs, that's not allowed. And for the third one, 3 goes to 2 different outputs, so that's not allowed. So the first one is an example of a function, but the second two are not, because each of them has one input that goes to 2 outputs. Okay, so main thing really so far, what is a function? A function is a rule or a relation that takes inputs, usually with the letter x, and maps them to or produces a set of outputs which we call y values or f of x. We have our 3 different ways of writing a function, and for it to be a function each input must only go to one output. So we're going to get into kind of more working with our notation in the next things.